Um, Hello, I'm Amy Phung, and we are doing a video lesson about the conic section from expanded equation ellipse version. Let me turn my laser pointer and let's get started. So for our lesson objective today, we're going to be finding and graphing the standard equation of ellipse from its expanded form. So we first off need to know what an ellipse is. An ellipse is an oval shape that can be graphed on a plane. So this is a horizontal major ellipse, which is the standard equation of that is x squared over a squared plus y squared over b squared equals 1. So when the a value, which is the largest value between a and b, is with x squared, then it will be longer horizontally. Now let's look at the vertical major ellipse. And we see that it's longer vertically. And why is that? Well, let's read the equation. X squared over b squared equals y squared over a squared equals 1. So we see that the a value is with y squared, meaning that it will be longer on the y-axis, making it longer vertically. So we also need to know how to complete the square in order to do this lesson today. So completing the square is a way we use to solve quadratic equations by making the left side into a perfect square. And please note that this can only be done when x squared is equivalent to 1. So how do we complete the square? This is just a brief mini lesson on how to do that. So x squared plus bx equals c. We're going to take this b value and we're going to divide by 2 and square it. So we get x squared plus bx plus b over 2 squared. And note that I add this term right here over to the right side because what we add to the left side, we must add to the right side as well. So that gives us equal to c plus b over 2 squared. So now we have this. What do we do now? So now we're going to take this term over here and factor it out so it becomes a perfect square on the left side. So how do we do that? Well, you could factor out the 3 terms right here, or you can use the simpler way, which is taking the b value and dividing it by 2 and taking x, and it equals x plus b over 2 squared. So you just take what b is divided by 2 and you put it over here and make it to a perfect square. And that's how you complete the square. So now let's get into the lesson about how to turn an ellipse from expanded form into an ellipse with standard form. So right here we have our example for today. It's 16x squared plus 9y squared minus 128x minus 90y plus 337. Well, equals 0. First off, we want to isolate all the variables, so we're going to subtract 337 on both sides. So now we have this. 16x squared plus 9y squared minus 128x minus 90y equals negative 337. Well, our next step should be grouping together the values that have an x variable and the values that have a y variable together. So now we have 16x squared minus 128x plus 9y squared minus 90y equals negative 337. So now that we have this, what are we going to do next? Well, we're going to start completing the square. So if you remember what I mentioned earlier, when we complete the square, we need to have the x squared equal to 1. So that's why we're going to have to factor out a 16, and then we're going to have to factor out a 9. So let's factor out 16 first. So when we're factoring out 16, we're just going to divide the values before the x by 16. So 16 divided by 16 is 1. Negative 128x divided by 16 is negative 8x. And then 9y squared divided by 9 is y squared. And negative 90y divided by 9 is negative 10y. And that is equivalent to negative 337. So now what are we going to do? Well, we're going to take the next step in completing the square, and that is taking the b value, dividing it by 2, and then squaring it. So we're going to take negative 8 and we're going to divide by 2 and then square it. So negative 8 over 2 equals negative 4, and then we need to square that, and we get 16. So negative 4 squared equals 16. Let's do that for this side too, this part too. So we're going to take the b value, which is negative 10, divided by 2, and square it. So negative 10 divided by 2 is negative 5. Negative 5 squared is 25. And then we're going to discuss what's going to happen to the right side after I simplify what is going on the left side. Okay, so here we have this right here. And you see on the bottom that says equals 144. Well, you're probably wondering, how does it equal that if we're just adding 25 and 16? Well, that's not the case. We are not adding 25 and 16 to the right side because if you recall earlier, we factored out a 9 and we factored out a 16. So this is not the actual number that we were adding to the left side. So let's multiply 16 by 16 first. So 16 times 16 is 256. So we add that over to the right side. And then now let's go with 9 and 25. So 9 times 25 is 225, so we add that over to the right side as well. And combine that all together gives us 144. So now what do we do? Now we are going to change this term into a perfect square. So we're going to take what negative 8 divided by 2 is, which is negative 4, and then we're going to put that over here, and that gives us 16, parentheses x minus 4 squared, and we're going to do the same on this side. So negative 10 divided by 2 is negative 5, so we put that over here, and that gives us 9, parentheses y minus 5 squared, and that equals 144. So we know that in ellipses, in their standard equation, they need to be equivalent to 1. And right here we have 144. So we must do something about it. And what do we do about it? Well, in order to get rid of this 144 and make it equivalent to 1, we have to divide everything by 144, both the left and right side. And we get x minus 4 squared over 9. And why? Well, 144 divided by 16 is 9. And 144 divided by 9 is 16. So we get y minus 5 squared over 16. And of course, 144 divided by 144 is 1. So now we have the standard equation of an ellipse. Yay, we finished solving it from expanded form into standard form. Okay, so now we need to graph this. In order to graph this, we need to look at where the center of this is first. So we see x minus 4 squared over 9 plus y minus 5 squared over 16 equals 1. Okay, so you're probably wondering, is it negative 4, negative 5? Is that the center? No, because in standard form, it's x minus the number. And since it's positive, it doesn't change the negative sign that's originally here in the equation. So it's actually positive 4 and positive 5. So the center is 4, 5. Let me move my picture down. So the center is 4, 5. So now we need to find the A and B value, because that is important to knowing if it's a vertical major ellipse or horizontal major ellipse. So we can see that the bigger number between these two is 16, and that is under y squared. So A is 4, and B is 3. And why is that? Why isn't A equal to 16? Well, under here, this is A squared. So in order to get the original A value, we must take the square root of 16, which is 4. And we need to take the square root of the B value, 9, which is 3. Now what do? Well, we need to figure out the vertices. And how do we do that? Well, we're going to take the center. We're going to do 4, 5 plus 4. But why are we adding the A value to 5? Well, if you look over here, we see that the A value is with y minus 5 squared. Therefore, we need to subtract and add 4 to the y value in order to get the vertices of the ellipse. And then for the co-vertices, we're going to do something that is similar to that, but with a b value and x minus 4 squared over here. So we're going to take the 4 in the center and we're going to add and subtract 3 in order to get our co-vertices. And that gives us our vertices are 4, 9, 4, 1, and our co-vertices are 7, 5, and 1, 5. Now let us graph that. Let me move my picture. I'm not exactly sure where I should move this. So now let's start to graph. So let's graph our center first, which is 4, 5. Let's graph that 4, 5. Okay, so now that we've graphed the center, we're going to graph the vertices. Let's go with the vertices 4, 9 first. And then now let's go with the next vertice of the ellipse, which is 4, 1. And then now let's graph our co-vertices, 7, 5. Let's go up to 7, 5. And then let's graph our next one, which is 1, 5. Now that we've plotted our points, we are now going to connect the dots to give us our ellipse drawn right here. And as we can see, it is a vertical major ellipse because the a value is with y